So Mark Levine, who is our next speaker, is or has been a colleague of Art's for a quarter century or so, I would estimate. He earned his PhD here at Berkeley in chemistry in the 1970s and has been affiliated with the Lawrence Berkeley National Laboratory in the Energy Environment Technologies Division since 1978. He was originally appointed as deputy head of the energy analysis program there and became its head in 1985. And then in 1998, he assumed the position that he currently holds as director of EETD, this division that is one of the larger divisions at the laboratory and the one that Art was affiliated with while he worked at the lab. In addition to his tireless and effective contributions in leading the division overall, Mark has remained active as an investigator in energy analysis with a particular interest in China. And so the subject of China and China's energy use and energy efficiency is the topic of his presentation this morning. Mark?
Thank you very much. Is there a pointer before I start?
Using the slides that has a pointer as the third button.
Okay, so that, and then, okay, good. So, by way of introduction, I wanted to say a few words about art and the pleasure it gives me to be able to speak at this event. I wonder if Art's here.
I will get it.
He's actually a despicable sort of guy. Could I tell you stories about what he's really like? Oh, Roz is here. Roz, should I tell them stories about what Art's really like? Was that a yes or a no? Well, I'm going to do it I'll tell you what, I'm going to start on China and then go to Art. How about that? So, no, I'll do it. Look, I value him for his presence when he's here. I even value his impact. I even value for the effect he has when he's not here, which is really quite amazing. This is one of the very few people who can dominate one's mind and one's vision even when he's out in the hall doing something else. In order, I value Art as a friend, as someone who is an exemplar of a field of great importance, and as a colleague. As a friend, he is as generous as anybody I know. Irma and I have had wonderful trips with Roz and him to China, to Africa. I've had other trips with him to Egypt, to the Ukraine, and we have a ball at Art and Roz's house. But the main thing is his generosity, which I don't know of any parallel. As an exemplar for his field, energy efficiency, if we had had to invent somebody who was known as the founder of the field, who better than Art to represent what we stand for? I can't think of anybody. No. If I could summarize. Oh my. Uh-oh.
What does that coffee have in it?
I didn't see that.
No food and drink.
Hey, Mark.
Oh, it's his birthday.
So, friend, exemplar for the field he created, and colleague, You know, when you go to work with somebody and they make you feel like you've said and done things that are really good, that is just fabulous. And art does that with pretty much everybody who does something pretty good, and even does it with people who have ideas that aren't so good, because Art himself has been known to have ideas that aren't so good. Can I say that, Roz, after everything else I've said? Now, moving from art to China, not a difficult transition. I've entitled this Energy Efficiency in China, Glorious History, Uncertain Future. This is sort of the way the Chinese might characterize all this. So let's start with the boy, I tell you, this is a dangerous, dangerous territory. I would say that for what we're trying to accomplish in energy efficiency, it is not easy. We need the strongest of the strong. And so if we see people tippling over during the day, that's just how it works. Then I have a part 2 and a part 3 that I'll get to as well. So part 1 is preceded in good dialectical fashion by an inglorious earlier history. So my executive summary, in China things were bad in energy for 3 decades. Deng Xiaoping came to power. Things got a whole lot better thanks to a group of about 100 academics who had the courage to go up to Deng and say that the policy in China in energy was wrong. And let me assure you, in 1978, 79, if you said that in China, you had to have courage. Deng listened. Things were much better for 2 decades. The market became king. Energy went off track. And then there are solutions. So, phase 1, Soviet-style energy policy, 3 decades. Energy grew very fast. In that first period from here, 1950 to a little after 1960, I'm sorry, whoops. Okay, so let me note that this is GDP, this particular purple chart. And you notice GDP started in sort of whatever units these are at more than twice energy and ended up at about the same as energy. What that tells you is that energy through this whole period from 1950 to 1980 was growing substantially faster than GDP. And in fact, in that first period, it was growing at 28% a year. Now, that's overstated because here you see the Great Leap Forward, which really could be called the Great Leap Backward. There was the Great Leap Backward. It took quite a while to recover from that period of time when people went into their backyards in southern China and dug for coal where it wasn't, and so forth. Okay. Now, the result of all this was that China developed one of the world's least efficient and fastest growing energy systems. Energy was virtually too cheap to meter in China. Like Russia, the communists believed that it was a necessity, which it is, and therefore should be priced very low, which it should not. Initial reforms, I talked about this key meeting of 100 academics. They identified major changes that needed to be made. Remarkable thing about China is that when they decide to do something, they do it. You know, where else does that happen? They do it fast, very fast. By 81, most of these aspects of energy efficiency policy in China were in place starting with zero. That is to say, in 2 years, China went from Russia to California in its policy on energy efficiency in 2 years. But these were not just words, these were real changes. For example, they went from a zero investment in energy efficiency to more than 10% of total investment in energy devoted to energy efficiency investment by 1982. From 0 to 12% of total energy investment by 1982. So in a 2-year period, they ginned up the China Energy Conservation Investment Corporation. This is almost art on steroids at this point. Just hard to imagine and frightful to think about. If we look at the whole period, China went from energy growing substantially faster than GDP from 49 to 1980 to energy growing at less than half as fast as GDP from 1980 to 2000. And here you see actually two charts. One is the GDP estimate on top that is the official GDP estimate, and the other is one that was corrected as best we could. And even then, energy growth was half that of GDP. And this was not a coincidence. This was by plan and policy on the part of the Chinese. I learned about all this in 1988 and was flabbergasted when I went to China for the first time because nobody outside of China knew about this. And in fact, I learned in 1988 that there were no ties between the US and China in energy efficiency. And the Chinese convinced me to stay longer. I did. We formed a China Energy Group. Helen Wheeler is going to pass out she's my assistant, is going to pass out a brochure that summarizes the work we've done with China on energy efficiency since 1988. Now, on carbon emissions, if the Chinese, in fact, had not figured out that it was necessary to reduce the growth of energy use to less than half that of GDP, they would have exceeded U.S. carbon emissions before the year 2000. Now, there is some inconsistency in that in the following sense. If the Chinese, one of the main reasons the Chinese recognized that they had to do energy efficiency is that they realized that if they didn't do it, the investment in energy supply would demand so much of the capital resources and resources of the country that they wouldn't be able to achieve other essential investments for a more balanced economic growth, and therefore their economic growth would not have been as successful. They also would have run out of air, as John Holdren suggests. The air down low would have been truly unbreathable. Well, it is unbreathable. It would have been much, much worse. Okay, transition period, the movement to the market. What happened, long story short, is the Chinese sort of willy-nilly dismantled different parts of their energy efficiency policy apparatus, thinking that the market will take care of all these problems. And even though the people in authority in energy efficiency understood very clearly that that was a mistake, their authority was greatly diminished because the market was in charge. Now, we also had a takeoff of consumer goods, but that does not account for any significant major problem, as you'll see in a second, I think. Well, to the year 2000, the takeoff of consumer products started in the late 80s or mid 80s and continued through the present. But until the year 2000, you really don't see any major impact on energy. Okay, now let's talk about the year 2001 to the present. Executive summary. China faces a serious new energy crisis. Most people in China see this as an energy shortage. But as I was told in 1988 when I first went to China and there were severe energy shortages, I was told by one person whom I talked to, he said, there's no energy shortage in China. There's no energy crisis in China. There's a crisis of policy in China. We have plenty of energy. We just need to use it better. Well, we're back to a bad place again. A key is investment. Okay, so let's talk about it. Energy, well, here's some, remember, these are the numbers I plotted up earlier, GDP and energy. Now look at 2001 to 2005, and what you see is energy growth is now outpacing GDP for the first time since 1979. There was not one single year between 1979 and 2001 where energy grew faster than GDP. There's not one single year after 2001 where energy has not grown faster than GDP. So things are, I like to refer to it, I don't like to, but I often refer to it as China has fallen off the wagon. So let me relate a few of my own personal experiences. I go to China quite often. I was in a meeting, quite a high-level meeting, and I realized that the emperor not only had no clothes, but nobody was saying so. There were vice ministers and so forth at the meeting concerned with energy, so I was able to get myself put on the agenda, and I basically said, you know, things are just rotten in China. Or is that Denmark? Well, we didn't talk about Denmark. And my argument was the following. Where's Deng Xiaoping when you really need him? In 1980, Deng Xiaoping said, we're going to quadruple GDP in 20 years, and we're going to double energy. In 2000, the Chinese government said, we're going to quadruple GDP between 2000 and 2020, and we're only going to double energy. Well, look at this. They're perfectly on a path to quadrupling GDP right now until things run into trouble, because look what's happening to energy as compared with the path that they said they were on. Okay. This is big trouble. And of course, we're talking about China because, as you heard from John Holdren and others, you know, if we don't deal with these issues, if the Chinese don't deal with these issues, then the world really has no chance on climate change. Now, it's not as bad as it sounds, or is it? Well, wait a second. Well, let's stay on the bad side for a minute. Here's an impressive number. In fact, this was mentioned in a talk earlier today, too, about this 1,000 megawatt power plant per week in China. How much is that? Well, Three Gorges was 18,000 megawatts, but they built it over 10 years. Last year it was, I think, 74 gigawatts. What had the Chinese government expected 5 years ago in terms of new power plants? Oh, about 20. This is, I think, the largest construction project in the history of the world, the construction of power plants in China. I don't think there's anything that has ever rivaled it. And it's unplanned. and the Chinese government has no control over it. They could either stop it all or let it all go, as they learned last year when they closed it down. There's one person in the Chinese government who has authority over power plants below the premier. And so he stopped all, he can't review all the plans, so he stopped them all. And in 3 weeks, you know, his job was rather unpleasant, and they restarted them all. So this really is a problem, and it isn't just a problem from a global perspective or various other perspectives. It's a problem from the point of view of the Chinese government. Okay, they're not thrilled with it. So the future. Executive summary of part 3. Things could get worse. Actually, that's not true. Things cannot get worse. The information got up to the highest levels of the party in the government. The Politburo came out with an announcement last November, which, when I read, was a one-page summary of their plenary, which said that had 2 goals: a reiteration of their goal of quadrupling GDP in 20 years, and a statement that they will reduce energy intensity by 20% in 5 years. Now, first of all, the fact that it came from the Communist Party is mind-boggling. The Communist Party does not interfere with the activities of government unless there's a crisis. The party appoints the government, but it doesn't make these statements typically. Thereafter, the National People's Congress reiterated this goal. You can't go anywhere in China without hearing this goal. You talk to high officials, and each official is responsible for demonstrating that he or she has achieved that goal for the activities under that person. This is pervasive of China. I will tell you that the way this happened is that our closest colleague in China, the person we chose many, many years ago to be a close collaborator and we hoped would become the leader in energy policy, was invited by the Politburo to brief them on a study that he had done in collaboration with some of us. And at the end of that session, they had agreed to this 20% emissions target. Now, this is a typical art viewgraph, the end almost. I want to make a prediction, and it's only for 5 years, so you can hold me to it. I predict that Chinese energy consumption in 5 years, the Chinese will use energy at an intensity that is 20% less than today, or better. And I'm willing to bet anybody in this audience and give you 2-to-1 odds, 3-to-1 odds. You can negotiate the odds that the Chinese will do it. And here's why. Skills found only in China. Those are... That's a street sweeper. This guy's these two are my favorites. Let me ask the organizers, do I have 3 more minutes or should I stop here? I do, okay. So, anyway, but this is why I'm willing to, I mean, I should not have shown you these things. I should have taken the bets first, but, so, addendum on oil. You know, there's this tremendous concern that the Chinese are going to consume, quote, our oil, right? It is true that on world markets, the incremental oil demand over some years has been in China. Unexpected demand has been in China. And so it really has put pressure on world markets. However, this is total world, well, this is growth right here. This is world and this is Chinese. But it's the next chart that you really want to look at, okay? The blue is total world demand in oil. I think maybe I'm going to convert all this to terawatt years so that I can keep track of units that, you know, as we get older, remembering just one unit, it's probably easier. And then world oil trade is about 65% of that. Then you see in red the amount that China is using, and then you see in yellow the amount, I mean, those of you who have really good eyesight can see in yellow what China's net imports are. So I, for one, am not staying awake at night worrying about the Chinese consuming my oil. I also happen to believe that oil demand increases in China in the foreseeable future are not going to be nearly as great as some people think. So on those notes, I would like to conclude. I should say one other thing about Art in China, and that is Art actually is the only person I know in energy at LBL who beat me to China. He got there in the, I think, early 80s, wasn't it? 84. I didn't go till 88. He also set up our first exchange program in China. He arranged for Joe Wang to train a group of people in the 80s on energy efficiency in buildings. This is not particularly widely known. Art's problem is he's done so many great things that some of the lesser great things, you just don't have time to mention it. So thank you very much.
So the floor is open for questions. I'd request, at the suggestion of one of our audience members, that the questioners state their names before they ask the question and affiliation if you choose to. I guess I have to coordinate this. How about the gentleman in the green?
Don Groom, LBL. What is this thing, sustainable growth?
I'm not sure if that's a specific question or not, because for China at least, they're in the process of defining what that means. And it's extremely interesting. I originally took it as sort of, the Chinese are often like to use these wonderful terms and you're not sure quite what that means. But they have recently released a report that talks about inequities in China. And it compares China with other countries. And remarkably, China doesn't look that good. They talk about poverty in China. They talk about, all kinds of problems in China. And their definition, and this too is remarkable, that the government in China would have had such a report prepared and then release it and disseminate it. And they basically talk about growth, sustainable growth, being growth that solves one or more of these problems. Otherwise, it's not sustainable. So it's quite amazing. We could talk more about that. But that's one of the most interesting documents that I have seen coming out of China in many, many years.
So this gentleman and then here.
Don Aitken here on my own recognizance to celebrate your great occasion, Art. How do you reconcile the enormous increase in sale of automobiles projected for China with your optimistic view of not a great increase in oil or oil imports, since they have very little themselves?
Automobiles consume less than 15% of oil in China right now, and, yeah, that's right now, and I'm in a minority here, but I find it hard to imagine people wanting to buy automobiles if they can't use them to get from point A to point B. And I think that China have pretty much reached a point where in a lot of urban environments, the density is so great that buying an automobile might still be okay for status, but I think it's going to plateau out at some point. We're hoping to do some serious work on that subject in the next year to see if we can put some numbers on it.
Yeah, Mark, this is also a numbers question. Setting and meeting goals. Oh, Arthur O'Donnell, reporter with the Green Wire. Setting goals, meeting them requires good record keeping. Can we trust the Chinese record keeping, or is there an element of saving face in meeting goals?
Well, no, I think we can trust the record keeping for the energy intensity goals. Beijing just did its first ever detailed survey of energy use in Beijing in order to document what they're using now and what they're going to use in 2010. We talked to the Shanghai people, and I think they're going to do that very soon. You're going to find that happen all over the place. Up until not too long ago, we trusted the energy numbers, but not the economic numbers. Then, unfortunately, the Chinese tore apart, allowed their energy data bureau to disintegrate. They went from tens of people at the national energy, responsible for energy data at the national level, and thousands of people in the provincial level to small numbers of people at the national level, and various provinces had nobody doing energy data, so they didn't have good energy data. So right now it's a mixed bag. For example, just to tell one somewhat amusing story on this, the Chinese closed down tens of thousands of small coal mines. And so I went and talked to their person who does the coal statistics, and I said, you know, we look at the coal data, and are you counting coal from these mines that have supposedly been closed? He said, no, we're not counting that. I said, well, you know that many of them are in fact not closed. He said, yes, we know that. I said, well, in that case, shouldn't you count the coal from those mines? He said, no, we can't do that. I said, well, in that case, your data must be wrong. And he said, no, our data are right. These are official Chinese data. Well, you know, so we ran into those problems. But until 1997, the energy data in China were extremely good. And we produced an energy data book of China, and we went through all the data and reconciled numbers from all over the place, and I believed at that point that the energy data in China were better than in the U.S. by a substantial amount. It's not true today.
This is Mike Messenger. I wanted to follow up on this question of automobiles and demand growth. It seems to me that I've read some articles that suggest the big important thing to watch is the growth of the interstate highway system in China, and that it may precipitate the same type of thing that happened in the United States by essentially taking automobiles to the masses in the interior of China, and then the effect that you call the urban density effect would no longer hold. People would begin to travel, assuming that they had the disposable income to do so. So what are your observations about it? Is that network growing by leaps and bounds, as some articles lead us to believe, or is it really not a concern in the next 5 to 10 years, but maybe a longer-term problem?
Mike, that's a great question, and I just don't know the answer. That's one of the things we need to find out about. They have a good rail system, and so it's not obvious that you need cars, especially if when you get to your destination, you can't use them to get anywhere. But but on the other hand, there could be real advantages to cars. The real secret behind the auto industry in China, however, and maybe it's not a big secret, is that the Chinese have designated that a key industry because they intend to manufacture cars that they will sell to the rest of the world. And my belief is that they will figure out how to make a better car, a cheaper car, a more efficient car, and that it will get markets. And that'll be good for all of us. This Buick executive who did not retain his job even though he produced a cheap, highly efficient car in China, well, that was a mistake for Buick because that's where China's, I think, going to go. Although they're far from monolithic. I mean, auto executives in China probably are more like auto executives in the U.S. than they are like, you know, other executives, than other Chinese. So I think a lot will depend on how much this industry is shaped by the government. On your specific question, though, it's a great question. I don't know the answer.
We'll take one more question. I'm sorry.
David Claridge from Texas A&M. I don't know that much about the energy situation in China, except that last summer when I was in China, in an English language newspaper in Shanghai, it had a thing on energy saying that the energy efficiency of their economy per unit of GDP was, I've forgotten, either half or a third of that of the U.S. Is that on target, or is that, I mean, you didn't put a comparison up there, and it was a shocking kind of number, and I wondered if it could be right or not.
I think comparing energy use per GDP across different countries is best not done. For China, for example, what's the denominator? Is it GDP in the current exchange rate, or is it GDP in purchasing power parity? Therein gives you a factor of 2.5 to 3. So I think better is to do it in terms of energy intensity per unit product. Okay, let's talk about cement. The Chinese manufacture 45% of the world's cement. The Chinese cement-making industry has the same efficiency as the U.S. cement industry, which you might say is therefore a kind of modern cement industry. Wrong. If only the Chinese had a cement industry that was as good as the Indian cement industry, they would use 25% less energy. The cement industry in China is horrible. It's deplorable. It's every bit as bad as ours. It's among the worst in the world.
I think we'll say thank you again,
Okay.
Our next speaker is Dr. Ashok Gadgil. Ashok is a senior scientist at the Lawrence Berkeley National Laboratory. He is also an adjunct professor in the Energy and Resources Group. He's a PhD student of Art Rosenfeld, earning his PhD in physics here in Berkeley in 1979. He's another example of physicist gone bad or something like that. Maybe physicist gone good. Physicist gone wild. Ashok, I can testify from personal experience, has an unbelievably fertile and imaginative mind, and an enormous conviction to using that for public benefit, particularly among people who are underserved traditionally. He and I have collaborated on the things that are probably the least important that he's done, but still wonderful nonetheless, on indoor air quality studies, pollutant dynamics in the indoor environment, mentoring together several PhD students, and I've enjoyed my interactions with Ashok tremendously in those encounters. What he is best known for is an invention called UV Waterworks, and this is the subject of his presentation this morning. He has won a raft of awards for this invention. I can't keep them straight, even though I would like to be able to, but I do have it on first-hand account that the thing that Ashok is most proud of associated with this is that he is a featured character in an educational book for 4th and 5th graders, written to explain how engineering is done. There's a series of 4 of these books. One is on environmental engineering, and Ashok is the highlighted character in this, talking about UV Waterworks. And so with that, let me introduce Ashok Gadgil and bring him to the... Now all I have to do is get the machinery working.
Thank you. To start with, I understand that some of the staff that helped organize this has to leave at 12, and I just want to express my thanks for the extraordinary work that was done to get this whole assembly together of very bright, very creative, outstanding people to celebrate Art's birthday and the Fermi Prize. So thanks to Adrian Hink and the ERG staff in particular who have to leave, I think, at 12. So I am going to talk about the Rosenfeld effect applied internationally. I have the fortune of being arts graduate student, and it was extraordinary for me to watch Art's pace of work, his intensity, creativity, willingness to roll up his sleeves and fight with PG&E, for example, who tried to get David Goldstein fired when David Goldstein was working as Art's graduate student. All of those interactions were truly exemplary for me. So, my 3 lessons, which I'm going to kind of expand on a little bit. One is look for a handle on the problem when the problem looks really, really difficult. And you'll see how I applied them, and we'll go a little bit in detail. Don't just sit there, do something when you find a terribly serious problem. And lastly, better to light a candle than curse the darkness. And we'll talk about Darfur situation. So to start with, I'm going to talk about looking for a handle on the problem of compact fluorescent lamps for the poor in the developing countries. I don't need to go into details about the lamps. You know that the luminous efficacy has really jumped up from about 10 lumens per watt here. In the developing world, lamps are made less efficient because of voltage fluctuations. So they are designed to run cooler. So even though American incandescent lamps may be running at 15 lumens a watt or 12 to 15 lumens a watt, incandescent lamps in the developing countries have to survive voltage spikes. So they run cooler, and then you get only about 10 lumens a watt here. But the compact fluorescent lamps, on the other hand, of course, run on different physics, and they still deliver the same high luminous efficacy as they do anywhere else in the world. So as most of you know, and as Mark mentioned, there are massive power shortages in the developing countries. If you went to India, you would find major cities having power cuts, complete blackouts, which are published in the newspaper. Ours are published in the newspaper, and these blackouts run maybe once a week, so that it's a rolling blackout from city to city for maybe 8 hours a day. In some cities, blackouts are extending every day, sometimes twice a week, so all of this is getting worse and worse. Blackouts are, of course, peak power, peak demand being unmet by the installed capacity. The peak demand commonly in almost all developing countries is driven by residential lighting, because the first thing you do is you electrify homes to improve the standard of living. Everybody gets an incandescent lamp. 6 p.m. to 10 p.m. they turn the lamp on, and you have a peak demand problem. So you start investing heavily in the power sector to meet those peak demand shortages. And right away you find that you need to invest at such a high rate that you have to draw investments away from other critical infrastructures, such as education or transport and communication and primary health care to the public. Now, trouble here is, of course, that the residential lighting that drives the peak demand is mostly in the bulk of the population, that is low-income households who all use ordinary incandescent bulbs. Okay? The compact fluorescent lamps, which we are familiar with in California, use, of course, 5 times less electricity, last 10 times longer, and also cost 10 times more, which is just fine because they last 10 times longer. So they would pay for themselves just on capital cost basis or the lamp price basis, except that the poor consumers are very sensitive to first cost. They hugely discount future savings. They want bread on the table today. They're living hand to mouth. Okay? So they are not going to buy a compact fluorescent lamp. And they are the ones who need to have these compact fluorescent lamps in their homes if we are going to drive down the peak demand. Okay? So the poor, which is say 95% of the population is what we are talking about, not poor at the bottom 5%. Okay? The 95% of the population prefer ordinary light bulbs. And then there is a social policy which says that because these people are poor, you have to subsidize electricity so they at least have a lifeline rate. And that subsidized electricity undercuts unsubsidized energy efficiency. In other words, their electricity savings from installing an energy efficiency device are even smaller because per kilowatt hour they are paying less than the true cost of production of electricity, because there is cross subsidy between industry, which pays a higher rate, or rich customers, high consumption customers who pay higher rate, and the bulk of the low income customers who receive subsidized electricity. So now we are in a kind of a jam. We have these peak power shortages driven by residential lighting by poor customers for whom it makes no sense to buy a compact fluorescent lamp. That's the situation I face when I try to see, how do you get a handle on the problem? Look to Art. How does he do this? So the solution is to frame the problem larger. Recognize that utilities actually lose money when they sell electricity to this bulk of residential customers because it is subsidized. They lose money so heavily in India, for example, that they are almost always in the red. The government extends them loans, which they don't pay back. But if they don't get the loans, of course, the subsidy will disappear, which will get the government voted out of power, which means the government keeps on giving them loans, and the state utilities keep on losing money, bleeding money, go in the red. Of course, they are under pressure to somehow not lose money that fast. So it's in their interest to sell less electricity, if they can, to the electrified households. So if you frame the problem with a larger frame, bring the utilities into your institutional setup, now we can say to the utilities that if they transfer part of the subsidy which they put on the electricity into energy efficiency, they would sell less electricity and lose less money. This kind of looks so obvious, as Art would say, such a dumb idea. Why don't they do it yesterday? The funny thing is, what looks like a dumb new idea, what looks like a dumb idea, but when it's a new idea, it looks very hard to sell to somebody, particularly if the utilities are run by government bureaucrats whose careers depend on not making a mistake. You're rewarded for not making a mistake. You don't have to do great things. If you're in the government, if you don't make a mistake, you go very far. So our goal is to design a program that brings the utility in its own self-interest, to subsidize and promote compact fluorescent lamps through lease purchases and other means. Okay? So this effort brings to the table utilities, CFL manufacturers, because they would certainly like to develop a market. Okay? Researchers, both on the hardware side and on the social sciences. Public interest groups, make it work. It's not easy to make it work. It's just one line, one short sentence, make it work. It's very hard, but we tried. Back in 89, 91, we set up this project called Bombay Efficient Lighting Large-Scale Experiment, or BEL. And it's like running into a brick wall. It was a crash test and didn't work. But it failed not because of technology or economics. It failed because of institutional politics. So when that happens, you kind of pick yourself up and dust yourself off and try again. So that was the Mexico project in Illumex, with funding from GEF and a Norwegian grant and a loan from the World Bank. And over 93 to 95 was the 2 years preparations. It worked beautifully well. More compact fluorescent lamps went into the households of low-income customers than were planned in the project, by almost 50% more. I was the originator of this. I played a role in this, and then these two projects were just run by International Finance Corporation, which took it to larger and larger scales. The most recent one concluded is Efficient Lighting Project. Covered 7 countries, extraordinarily ambitious, a great success, shown across cultures across different continents, across different customer behaviors, across different market barriers. Is a stupendous success, and in fact there is a web page which is efficientlighting.net, www.efficientlighting.net, where all 400 documents of how these programs were done in all these 7 countries are now public domain. And that's a tremendous success story, but started with a failure, of course. So now we come to UV Waterworks, something that Bill mentioned. And in some sense, this is the story about not just sitting there, do something. I grew up in India, went back after my PhD, worked there for 5 years, and saw that safe drinking water continues to be inaccessible in every district of India. And when I talk to people from other cities and other parts of the developing world, I see that this is not a problem confined just to South Asia. I mean, it's practically every developing country, every metropolitan city in the developing country as well, whether it's Jakarta or whether it's Cairo, people don't trust even the city supply water, apart from the rural people who of course don't get safe drinking water. Okay, so here are some pictures of what it looks like in terms of rural drinking water supply. But next year would be the first time that more than half the population of the world will be in cities. Okay, this is not the dominant fraction of the population from next year onwards. But those cities are exploding in the developing countries, where the slums that rapidly grow have greatly exceeded the supply capacity of the infrastructure, which typically means that people who are in the slums or people who are mostly in the cities, anywhere in the developing world, get water for only a few hours a day. My mom's apartment in Bombay gets 4 hours of water a day, and that's a luxury. If you are in Chennai, which is Madras, you get 2 hours of water per day. And when you don't have pressurized freshwater supply, even in an urban setting, then you have intrusion of groundwater into the freshwater supply pipes, because some smart people put pumps and suck water out of the pipes when they do get water supply. So the pipes have negative pressure. And almost throughout the world, including in Berkeley, sewage lines leak. They leak raw sewage into the groundwater, which is why you would notice that on Berkeley campus there are cautions saying don't step in the Strawberry Creek that runs through the campus, okay? Because through the hills the sewer pipes are broken. Same thing happens in Bombay, same thing happens in Delhi. So groundwater is contaminated with raw fecal matter. That's what gets into the pipes, and that's what gets supplied when the pressure comes on. So in other words, in the cities as well, the water supply, even though chlorinated at a supply point, by the time it reaches the tap, is contaminated with raw sewage. People go to great lengths in the rural areas to get access to safe drinking water. The way you define access is defined differently by different countries. Typically, you would say, most developing countries would say, you have access to safe drinking water if you had water within a kilometer or 2 from your house. So you would walk there and you would get some water. This woman doesn't have access to safe drinking water, but if this was a hand-dug well, the government would count her as having access to improved water supply. There are 1.2 billion people like that who don't have access to safe drinking water according to their own governments. But governments of India and Egypt and Indonesia don't count urban residents as not having access to safe drinking water. In reality, as I described, their water supply is compromised as well. So if you add it all up, 2 billion people don't have access to safe drinking water. So I started working on this problem in '93 because there was an outbreak of a mutant strain of cholera in India that soon spread to Bangladesh and on to Thailand, where standard vaccines, cholera vaccines, were ineffective because the protein coat on the bacterium had mutated. What we were looking for is something that really meets or exceeds WHO and US EPA criteria for disinfection. That's energy efficient. Our design used 60 watts to disinfect 1 ton per hour. Something that was really low cost, so something that disinfected a ton of water in 4 US cents, used only reliable and mature components, could treat unpressurized water. You didn't have to wait a long time. In 12 seconds, the water would cross this device. Low maintenance, no overdose risk, and fail safe. So if electricity fails, for example, this device shuts off throughput of water, which means whatever comes out of this device is actually always going to be disinfected water. Okay? The design looks so damn simple, Art would say dumb. It took us, it's easy to make a complicated thing. We could have done this in a couple of months if we were to build a complicated device. But making it simpler and simpler and simpler took a lot of time. In a couple of years, we had it finished. This device, as I said, disinfects about a ton per hour of water, uses 60 watts. And this is the basic concept, okay? How it works is UV light basically pulls together carbons in adjacent thiamine pairs on the backbone of the DNA. This is only half of the strand. You might remember this. Half of the DNA, the phosphate backbone, adjacent thiamine pairs. They get covalently bonded either this way or this way when exposed to UVC radiation. Once they are covalently bonded, the DNA is useless for the organism. The organism is unable to replicate, dies soon thereafter. And we designed it so that the nominal dose to water was about 120 millijoules of UV energy per square centimeter, when the US EPA requirement is about 40 millijoules per square centimeter. This big factor of 3, safety, is because things will not work so well in the field. So you need to make sure there is power sag or whatever goes wrong, you still need to be able to disinfect the water. The funny thing is, even with this dose, it works out to be just 4 cents per ton of water to disinfect, just if you had the bare bones device. Turns out, of course, people in the developing world don't want a bare bones device. They want a pump, they want a mechanical filter, they want a carbon block filter, they want all of the rest of it. And they're very price sensitive. They're not going to buy the device. They would rather buy the water, which means it's pay as you go. And we'll come to that in a second. So we tested the device in India first, then in KwaZulu-Natal, licensed to a California startup. Waterhealth.com is a website where you can see what they have been doing. When they rebuild the device, this is what it looks like. If you took the cover off, you see the aluminum reflector, and you see some of the electronics and the stainless steel. So in Philippines, in Manila, in low-income slums, here is Water Health Philippines set up to sell drinking water on a pay-as-you-go basis. It's a franchise operation. It pays for itself. Nice, glass and stainless steel and white tiles and white smocks, and you would say, wow, this looks like some kind of pharmacy. But the people who come to buy, and these guys will actually, it says, we deliver. You can't read it that well. But there is a little, tricycle, foot pedal tricycle that will deliver water to homes. People who buy from here cannot afford to boil their own water. By the way, boiling water always works, as we all know when we go camping. But boiling water is consistently, completely unaffordable to people in the developing countries, whether they live in cities or whether they live in the countryside. It's out of question. Chlorine, of course, works if you had access to chlorine, and there are pros and cons. So this is something back in 1999. This continues to move forward. In Mexico, the health department from the state of Guerrero decided to buy 60 of these units and have them installed at the cost of the health department so people could come and collect water for free. This didn't work so well because there was no incentive to keep the stuff going. The State Department, the State Health Department paid a maintenance team of engineers who would actually come and fix this, $20 a month or something. But given the bureaucracy and given the complicated logistics, the engineers who are supposed to do the maintenance keep on getting paid, even though the faucet here is broken. People, for example, would hang this bucket typically from this little faucet. The faucet would break, the whole tank would go empty. The local guys would say, it's not my problem, I'm supposed to get free water out of this. So about only 1/3 of the units were working when we revisited this place in 2004. But that's an institutional linkage problem which has not plagued the Philippines installations. In India, a totally different approach now, pay as you go. This is a huge concrete structure, covers with UV waterworks inside, people coming out to pick up the water, and the village nurse is very pleased with the 15-liter container. This is a more mature program than the previous slide, where people actually buy or get a refill for this for 1 Indian rupee for 15 liters, that's 2 cents US. For full cost recovery, which pays for salary of the operator, pays for UV waterworks, pumping, civil structures, education program to make sure that people understand the importance of health and hygiene. Here is the operator whose salary is paid by that 1 rupee or 2 cents every 15 liters setup. But the point is, that is all self-sufficient. It's not charity. It doesn't have to be charity. It pays for itself. Okay? Now, I have a really important topic to talk about, which is Darfur cookstoves. Sudan is the largest country in Africa. 1/4 of the total United States area, including Alaska and Texas. 93%. 93% is desert. Darfur is the size of France, which is on the west part of Sudan. About 300,000 people have been killed. 2.2 million have been driven out of their homes into dense, crowded refugee camps. This is what the camps look like when we visited them back in November last year. In 2004, the US State Department called it genocide. The trouble is that refugees get some food, rations, but they have no fuel to cook. So they have to leave camps and chop down the wood, bring that in. And there is, as you can expect, an ever larger zone of denudation around the camps as the vegetation is stripped. So here is a woman walking back to the camp, collecting a pile of twigs. Basically, we found the mean diameter to be about 3 centimeters. And they routinely risk rape and mutilation when they must leave the camps for gathering the fuel wood. Typically, the trip is 3 hours out, 1 hour of twigs collection, 3 hours back. That's what's happening in South Darfur. In North Darfur, situation is worse. They cook on simple 3-stone fires. Here is 1, 2, and 3, and they light a fire underneath. There is trade in fuel wood because there is like trading in risk. Some of the refugee women who refuse to get exposed to rape again sell part of their food rations, get cash. With that cash, buy fuel from either middlemen or from other refugee women who are willing to take the risk. So there is a price for fuel wood, and that costs about $1 worth of fuel, if you want to look at what's the price there. So last year we took a few stoves to Darfur camps, and we used their fuel. We had them do the cooking. We used their pots, and we used their cooking methods with their food, side-by-side comparisons. And we used only about half the fuel wood compared to what they were using with 3-stone fires. So the savings would be on the order of $160 annually. We had side-by-side tests. There is a 3-stone fire. Here is a kind of $10 stove, and being done in a Darfur camp. Okay. In this semester at Berkeley, 4 students, a team of 4 students in the class that I'm teaching, worked to improve the stove further, and now it needs only about 25% of the fuel wood compared to the 3-stone fire. The price has gone up some. We work with CHF International, which is a nonprofit. They are funded. They're eager to make and disseminate stoves of this design. We need 300,000 stoves. Each stove costs $15, but because the stove saves so much fuel, it shouldn't be a problem, we think, in terms of how the stoves should pay for themselves. Question is, how do you ramp up? How do you get something from where we have it now to the hands of CHF International? So we need to do this. We hope to do this in the next few months. Of course, there's always a short of funds, but art is a good example to say, say we can do this. All we need is a little bit of money to make it happen. Here's the website if you want to know more how to make it happen, and I'll take questions.
Hi, my name's Art Rosenfeld. Ashok, put your last slide back up. Yeah. Look, I want to make a sales pitch for Ashok. If you think that his being an ambassador to do compact fluorescent lamps or clean water or cook stoves is a good idea, I want to say that he has 2 accounts, one on campus and one at LBL, to which you can contribute. The campus account has a very low overhead of 6%. The LBL account has a 0 overhead, which is pretty good. There's one interesting problem with the LBL account, and that is the cook stoves which Ashok developed turn out to be DOE property, so he can't ship them to Darfur. So you have to contribute to his campus account for that. A number was mentioned today of $375,000. If anybody in the room cares to contribute to Ashok's Darfur project, and I think he will interpret those funds broadly, I can assure you he will be matched. So this is a sales pitch, and there's the website, and there's Ashok. See him at lunchtime. Thank you.
We have a few minutes for questions, if there are any from the audience. Dan.
Yeah, Ashok, it's great to see the cook stove work. Dan Kamen from ERG. It's great to see the cook stove work, and I'm curious, before the tensions erupted, actually Khartoum had one of the best improved cook stove programs in all of Africa in terms of designing stoves. And yet you've got one stove model here, and given this is one of the few places where the long walk to fuel is actually a really critical impediment, many places where you can make an argument fuel is available and the issue is land change and time and all. How did you decide initially that this route versus, for example, solar ovens or various things that often don't work, but here is a place where they would fit? How did you decide which technologies to select, given the range of Sudanese experience, not totally friendly to Khartoum, but also the wider set of stove models available in the literature?
Excellent question. Absolutely. There has been about 30 years experience of building efficient cook stoves in India, China, Africa, all over the place, either of metal or of mud. And our goal was to figure out which cook stoves would actually can be quickly disseminated without loss of quality in 300,000 households or families. There was, in fact, a program promoted by ITDG to make mud cook stoves, and 50,000 of those cook stoves have been disseminated throughout 2005, and we went and tested them. Effectively, what had happened was a mud cook stove, a mud efficient cook stove takes 1 day to build. which means you cannot mass produce them quickly, and the tolerances degrade as you try to disseminate the knowledge of how to build them. We went and tested what they had got. It's like the children's game of telephone. By the time the knowledge had gone down to the people who were actually building the stoves, the mud cook stoves that we tested were abysmal. They were only 10% better than a three-stone fire and produced about twice the smoke, so far as we could tell. So people had typically built the stoves because they got a small amount of payment for building them. Then they would take the stove home. Sometimes they would turn it upside down and use it as a stool. I mean, you have something in the house. These guys have nothing otherwise, so they use it as furniture. Sometimes they use it for storing things, but that's what the problem with mud stove was. Regarding metal stoves, we actually took 4 different stoves with us and tested them, and the best one is the one I talked about, given limitations of time. Solar stoves have been tried in January 2005 in the camps, and they don't work well with the Darfurian cooking method. They need, the Darfurian refugees need to fry onions to make what is called mullah, the sauce. And that requires a much higher temperature, and you can't go in there unless you have a concentrator, which makes life very complicated. So we backed off from the solar ovens just for that reason.
We have time for one more question here. Sorry, you need to introduce yourself and use the microphone, please.
Bill Fulkerson from the Institute for a Sustainable and Efficient Environment. Ashok, it's a pleasure to meet you in person, having collaborated with you for more than a year electronically.
Same here.
What's the possibility in the Darfur case of getting these stoves manufactured in, say, Chad or whatever, and actually making a business of it, and selling them to the 300,000 that you're talking about for at least some return, and so that you generate something that actually could perpetuate in the whole region?
Absolutely. It's a great question, and you put your finger on it. I don't think we want to have 300,000 stoves multiplied by $15, multiplied by 1.5 for dissemination cost, program cost. We don't want to do it that way. What we would want to do somehow is do micro-lending so that savings from the stoves would pay for the stove that has been lent, allowing the next batch of stoves to be disseminated. CHF International has $80,000 from US OFDA to actually launch a program like this, which would effectively become a revolving fund to make these stoves propagate, and anybody else who throws money into that would also allow the pot to be larger for the revolving fund. What we are looking for is different. We are looking for ways to transfer and mature the design and hand it off to CHF. It should be done on a full cost recovery basis because the savings are so substantial. And it should generate local employment. It should be built in Darfur by local people. I mean, if not inside the camp, then in the workshops that CHF International wants to establish for the refugees. Right on.
Our guest of honor has, I think, the last word for this morning's session.
You asked me to make an announcement. Okay. We've cleared this up, and that is, if you make the donation to the LBL gift account, LBL can give the cook stoves to Darfur, and there is no overhead on that. So,
just a few minor bits of business. We will reconvene here to start at 1:30. We have a 90-minute lunch break. We will start punctually at 1:30. Ha-ha. We'll be close. And Director Chu and Professor Schneider, I still need your slides for the afternoon session. We're adjourned. Thank you very much.